Something happened in Poland that the defense world didn't see coming. A small Swedish team was handed a problem that NATO has been struggling with for years, a problem that has already cost billions of dollars to partially solve and still hasn't been fully solved. A problem that has caused some of the most expensive military hardware on the planet to be used in the most economically absurd way imaginable. And in 84 days, not 84 months, not 84 weeks, 84 days, they cracked it. Not with artificial intelligence, not with some exotic new technology that doesn't exist yet outside a laboratory. They cracked it by looking at what was already sitting on their shelves, connecting the dots that nobody else had connected, and building something that by the time it was tested in a real operational environment had already knocked 53 drones out of the sky. The system is called the LOK. It's made by Swedish defense giant Saab, and it may just be the most important counter-drone development in NATO's recent history. Stay with us because by the end of this video, you'll understand not just what the Loke is, but why the thinking behind it represents something far bigger, a potential shift in how NATO fights wars going forward. First, let's establish why any of this matters. Because if you haven't been paying close attention to what drones have done to modern warfare in the last 3 years, the urgency behind systems like the Loke might not be immediately obvious. The wars in Ukraine and in the Persian Gulf have fundamentally rewritten the rules of engagement. Not gradually, rapidly, almost violently fast. Every side in these conflicts is deploying drones at a scale and pace that was considered science fiction just a decade ago. Attack drones on the front lines, long-range strike drones deep behind enemy lines, swarms of cheap commercial drones retrofitted to drop munitions, sophisticated one-way attack drones cruising for hundreds of miles before hitting their targets. Drones have changed warfare full stop. And with that change has come an arms race of historic proportions. Nations around the world are scrambling to develop the most lethal, most scalable, most cost-effective attack drones they can build. And they are building them fast. Russia is producing the Shahed drone at a rate of hundreds per day. Ukraine is building its own drone fleet at comparable speed. Iran has become a drone exporter of global significance. China is watching all of this and drawing lessons. But alongside the attack drone arms race, an equally critical second arms race has emerged. The race to stop drones. Counter-drone technology, referred to in defense circles as QAS, which stands for Counter-Unmanned Aircraft Systems, has become one of the most urgent and heavily funded areas in military development worldwide. And here is where the problem gets genuinely fascinating. Because NATO, for all of its resources and technological sophistication, walked into the drone age with a serious gap in its defenses. And closing that gap has proven to be much harder than anyone expected. Here's the core problem, and once you hear it explained clearly, you'll understand immediately why it's so difficult. NATO's existing air defense architecture was built to stop threats that cost a lot of money. Cruise missiles, ballistic missiles, advanced fighter jets. To stop those threats, NATO developed interceptor systems like the MIM-104 Patriot and the IRIS-T, extraordinary pieces of engineering that are extremely effective at their job. But those systems use interceptor missiles that cost millions of dollars each. A Patriot PAC-3 interceptor costs approximately $3 to $4 million per missile. Now imagine using that missile to shoot down a Shahed drone, a drone that costs somewhere between $20,000 and $50,000 to build. You are spending $3 to $4 million to destroy something that cost $50,000. That is not a sustainable equation under any circumstances. But it gets worse because Russia isn't sending one drone at a time. It's sending dozens, sometimes hundreds, in a single night. Ukraine alone could consume an entire year's global production of PAC-3 interceptor missiles in a matter of months if it had access to them. The math simply doesn't work. You cannot fight a cheap drone swarm with expensive interceptor missiles indefinitely. The defense community has understood this problem for years. Between 2026 and 2030, NATO members and close allies are expected to spend more than $210 billion on air and missile defense. Much of that will go to high-end systems, Patriot, IRIS-T, SM, because the threat from cruise missiles and ballistic missiles hasn't gone away. But billions are also being directed specifically at drone defense, at finding solutions that offer what defense analysts call a workable cost-to-kill ratio, ways of destroying drones that don't cost more than the drones themselves. The scale of the development effort is staggering. The latest Unmanned Airspace 2026 Global Counter-UAS Systems Directory lists over 1,000 separate CUAS systems from more than 550 companies around the world. Net guns, intercept drones, electronic jammers, directed energy weapons, specialized missiles, guns, integrated multi-system platforms. The list goes on for pages. over 1,000 systems, and NATO still doesn't have a clean universal answer until perhaps now. Before we get to the LO itself, you need to understand the company behind it because Saab's history is central to understanding why they were able to build something this significant in 84 days, when most defense procurement programs take years just to clear the evaluation phase. SAB, whose name is short for Sensa Aeroplan Axial, or Swedish Aeroplane Corporation, was founded in 1937. In the nearly 9 decades since, it has grown into the dominant defense company in Sweden with a market capitalization in excess of $35 billion. It is by every meaningful measure the most strategically important company in the country. But what makes Saab genuinely distinctive in the global defense landscape isn't its size, it's its philosophy. Saab has spent decades building weapons that are known not for being the most exotic or the most theoretically advanced, but for being practical, reliable, and battle-proven. Weapons that work. Look at their track record. The GS-39 Griffin fighter jet, one of the most cost-effective fourth-generation fighters ever built, now being sent to Ukraine. The AT-4 anti-tank weapon used by militaries on every continent. The RBS-15 anti-ship missile. The Carl Gustaf M4 recoilless rifle, but a weapon so versatile it's been in continuous service since 1948 and is still being purchased by new customers today. The Giraffe radar family, the Trackfire remote weapon station. That last two names are important because those are the two core components that Saab looked at when they were handed the counter-drone challenge and realized they already had everything they needed sitting right in front of them. The Loke was first publicly presented in February 2025. It was the product of a collaboration between the Swedish Air Force, the Swedish Defense Materiel Administration, known as the FMV Saab, and a group of additional partners. The concept is elegant in its simplicity. Instead of designing an entirely new counter-drone system from scratch, Saab's engineers asked a different question. What do we already have that could do this job? The answer was two systems they knew extremely well. The Giraffe 1X radar and the Trackfire remote weapon station combined with electronic warfare components for jamming. These were integrated into a modular platform that can be configured in different arrangements depending on the mission requirement. The result is a system that can detect both physical targets and signals in the electromagnetic spectrum, giving it two separate and distinct means of identifying and neutralizing incoming drone threats. And because every component in the system is already in widespread use across NATO member states, training time is minimal, and interoperability is essentially built in. That's the concept. Now let's look at the components in detail because the engineering choices Saab made are genuinely worth understanding. Start with the radar, the Giraffe 1X. The Giraffe radar family has been in development since the 1970s. The first systems were delivered in 1977. Originally developed alongside the RBS-70 surface-to-air missile. Early Giraffes were mechanical two-dimensional pulse Doppler systems operating in the GH band designed specifically to detect low-flying aircraft in cluttered terrain environments, exactly the kind of environment where drones operate. Over the following decades, the family evolved substantially. The line culminated in the Giraffe Agile Multi-Beam, or AM, a three-dimensional passive electronically scanned array radar that has been widely exported and deployed in both land and naval configurations, where the naval version is called the Sea Giraffe. But the version that matters for Loki arrived in May 2014 when Saab unveiled the Giraffe 1X. It was a significant leap. The 1X uses an X-band active electronically scanned array, ASA, which means the radar steers its beams electronically rather than mechanically. That distinction matters enormously in practice. Electronic beam steering means faster scanning. It means improved reliability because there are fewer moving parts, and it means the ability to track multiple targets simultaneously. Essential when you're dealing with drone swarms rather than single threats. The 1X provides three-dimensional tracking, range, bearing, and altitude, which is critical when you're trying to engage small drones that fly low and blend into ground clutter. Its advanced signal processing can distinguish real targets from birds, terrain features, and weather effects. It provides 360-degree coverage with a full volume scan every single second. It's sensitive enough to detect what the defense community calls LSS targets, low, slow, and small, exactly what drones are. It also has counter-ram functionality, detecting rockets, artillery, and mortars for sense and warn purposes. The land variant has a range of around 47 miles. The naval variant extends that to around 61 millimeters. More recent improvements include the Giraffe 1X deployment set added in 2023, which improved transportability and readiness speed. And in 2024, a compact radar module was introduced that allows the entire antenna to fold into its housing at the press of a single button. The total system weight is under 330 lbs, light enough to be deployed on a light vehicle mounted on a mast or placed on a rooftop with minimal infrastructure. The US, Sweden, Latvia, and the United Kingdom are all currently procuring the Giraffe 1X for various applications. Its production lines are mature and well stocked. For Saab, integrating it into LOKI was essentially an off-the-shelf decision. The hard work was already done. Now let's talk about what the Giraffe hands off to once it identifies a target. The weapon system, the Trackfire Remote Weapon Station. Trackfire is a remotely operated weapon and sensor system that Saab developed specifically for integration on naval vessels, fixed defensive positions, and land vehicles. It was publicly launched at the DSI Expo in London in 2007 and entered service in 2012 with Finland's Navy, its first major operational deployment. In 2017, a contract with the FMV integrated Track F-Fire domestically onto Sweden's combat boat, 90s, and other naval platforms. And those boats, along with their Trackfire systems, ended up in Ukraine. Since February 2022, Sweden has provided Ukraine with 21 packages of direct military aid, totaling approximately 11.3 billion in value. That aid has included Archer artillery systems, Stridsvagn 122 tanks, air defense systems, and CB-90 combat boats equipped with Trackfire remote weapon stations. 10 CB-90s were delivered to Ukraine in February 2024, followed by an additional 16 in January 2025. And those Ukrainian deployments of Trackfire weren't just operational experience. They were a real-world testing environment. The lessons learned in Ukraine shaped what came next. In September 2025 at the DSEI Defense Expo, Saab unveiled the Trackfire Ares, a new variant specifically designed for counter-drone operations. And it is the version fitted to the Loke system. The Ares supports 360-degree azimuth rotation with an elevation range of 20 to positive 55 degrees. But the numbers don't fully capture what makes this system stand out from the competition. The real differentiator is something called Stabilized Independent Line of Sight, SILOs. Here's what that means in practice. The sensor module is decoupled from the weapon's axis and isolated from weapon recoil effects. When the gun fires, the recoil doesn't disturb the operator's view. The line of sight to the target remains uninterrupted throughout the entire engagement sequence. That capability dramatically reduces target acquisition times, which, when you're trying to intercept a fast-moving drone with a short window of engagement, is the difference between a hit and a miss. The Ares also enables continuous laser designation of a target throughout the entire engagement sequence, providing a highly accurate ballistic calculation, including three-dimensional target prediction. In plain terms, it doesn't just aim at where the drone is, it aims at where the drone is going to be. The system is modular by design. The core consists of a director unit housing the sensor module connected to a human-machine interface that includes a gunner's display, fire control panel, control handle, and video tracker. The crew sees everything. They identify threats, select the appropriate response, and engage, all without breaking visual contact with their screen. A dual command function allows shared control capabilities, reducing what the military calls the sensor-to-shooter cycle, the time between identifying a target and firing at it. In terms of firepower, the Trackfire Ares is highly flexible. It comes standard with the 30 hours 13mm M230LF Bushmaster chain gun, but it can also mount the Browning M2 heavy machine gun in 12.7mm, the FN Mag 58 general purpose machine gun in 7.62mm, MK19, and Heckler & Co. GMG grenade launchers in 40B Works 53mm, and lighter missiles. Non-lethal ejectors and electronic jammers can also be mounted in the LO configuration. The suite includes a Browning M2, an FN Mag 58, and electronic warfare jamming components. But the modular architecture means any of the other options, smoke launchers, spotlights, lightweight cannons, dazzlers, can be added as the mission demands. That flexibility is important because it means LO isn't a single solution system. It gives the operator two fundamentally different methods of neutralizing a drone: physical destruction and electromagnetic disruption. You can shoot it down or you can jam it. Having both options in one integrated package is something most QAS systems simply don't offer. Now here is where the story gets remarkable, and this is the part that has defense procurement professionals across NATO sitting up in their chairs. Most weapon systems take years to develop, in many cases decades. The Patriot system began development in the 1960s. The F-35 program started in the mid-1990s and didn't achieve initial operational capability until 2015. Even relatively straightforward systems typically require years of evaluation, testing, bureaucratic review, budget approval cycles, and field trials before they reach operational units. Lowe went from evaluation to delivery in 84 days. That number deserves to be repeated because it is genuinely extraordinary in the context of modern defense procurement. 84 days, 12 weeks, less than 3 months from the moment the evaluation phase began to the moment working units were handed to operational military units for field testing. The project was conceived explicitly as a speed run, a deliberate experiment to see how rapidly Sweden could evaluate and deliver a new counter-drone capability in response to an active and urgent threat. The evaluation began in January 2025. By the time spring arrived, units were already in the field. Carl Johan Bergholm, Senior Vice President and Head of Saab Surveillance Business Area, explained the approach directly. The team had to think entirely outside the normal product development framework. Instead of designing something new, they repurposed existing products and integrated new features around them. Having world-class components already on the shelf, the Giraffe and Trackfire meant the integration challenge replaced the development challenge. And integration, when you know your own products deeply, is dramatically faster. That philosophy is the beating heart of what makes LOKI significant beyond its technical specifications. It's a proof of concept for a different way of building military capability. Fast, practical, modular, cost-effective, but a concept only matters if it works. And LOKI has already been tested in a real operational environment, not a training exercise, not a controlled demonstration, an actual deployment. In September 2025, Saab confirmed that LOKI had been deployed in Poland for the previous 6 months. It had been operating at Malberg Air Base, where Swedish forces from the 21st Wing and later the 17th Wing were on NATO assignment. Their mission was base security, more specifically protecting Allied facilities, including a logistics hub that was central to the transfer of military aid into Ukraine. That is not a ceremonial posting. A logistics hub for military aid to Ukraine is exactly the kind of high-value target that adversaries have motivation to probe and disrupt. Deploying LOK, there wasn't a test in a safe environment. It was a live operational deployment. The results revealed through official photos and markings on the system told the story clearly. Markings on the deployed LOKE unit showed 36 successful interceptions of quadcopter-type drones and 17 successful interceptions of fixed-wing UAVs. 53 drones total in 6 months of active deployment. The official assessment from Lieutenant Colonel Christian Burleson, commander of the Swedish contingent in Poland, was characteristically understated in the Swedish military tradition. Effective air operations require robust ground protection. The systems we deployed significantly strengthened base security both for us and our allies. 53 confirmed interceptions, effective air operations in what was functionally the system's combat debut. The photos released alongside the confirmation also gave observers something interesting to analyze, a window into the philosophy of the entire project. The Giraffe radar in the Polish deployment was mounted on a pallet and secured with elastic tie-downs. The power supply ran through an extension cord likely connected to a generator. Next to the radar sat a red container equipped with antennas, clearly the jamming system. It hadn't been painted. There was no attempt at polished presentation. This was a working prototype built fast, designed to function, not designed to impress at an air show. That pragmatism is a double-edged aspect of the LOK story. On one hand, it reflects exactly the philosophy that made the system possible in 84 days. Speed over refinement, function over form. On the other hand, NATO integration standards require more than tie-downs and extension cords. Regulatory wiring practices, standardized mounting solutions, documentation requirements. These are real considerations as Saab prepares to market LOKE internationally and integrate it into broader NATO structures. The Swedish Air Force is currently training operators at the platoon level through the 21st Wing with full integration into combat units planned. But for wider NATO adoption, some elements of the system's construction will need to mature. None of that changes what the system has already demonstrated it can do. Swedish Air Force Chief Major General Jonas Wickman framed the significance of LOK in terms that go beyond the hardware itself. This is a clear example of how we are building the capabilities required and that we are prepared to deviate from normal processes to meet today's threats quickly. We need to constantly evolve and find fast and competent solutions to build a stronger Air Force. That statement reflects a genuine shift in thinking, and it's a shift that many in NATO's defense community believe is long overdue. The traditional defense procurement model was built for a different era. You identified a threat, You wrote requirements. You issued a contract. You waited years, sometimes decades, for the system to be developed, tested, evaluated, and approved. Then you bought it in large quantities and fielded it. By the time the system reached operational units, the threat it was designed to counter had often evolved significantly. That model worked reasonably well in a world where the pace of technological change and warfare was measured in decades. It does not work in a world where a nation can reverse engineer an Iranian drone and begin mass producing a domestic variant within months, as the United States recently did with the Shahed. It does not work in a world where drone tactics are evolving in real time, informed by active combat experience across multiple theaters simultaneously. The Loki demonstrates that there is an alternative. You can build effective military capability in 12 weeks. If you approach the problem pragmatically, use what you already have, and accept that a solution that works today is more valuable than a perfect solution that arrives in 5 years. One more element of Locke's design is worth highlighting because it speaks directly to its longevity as a platform. Because of its modular architecture, Locke is designed to evolve. The current configuration, giraffe, radar, trackfire, Ares jamming components, is the starting point, not the final form. Additional sensors can be added as they become available. Additional weapon stations can be integrated in significantly future-directed energy weapons. Laser systems capable of burning through drone components at the speed of light could conceivably be integrated into the LO platform with relatively little structural modification. Directed energy is widely considered to be the long-term solution to the drone cost problem. A laser that can destroy a drone has essentially zero cost per shot. The only cost is electricity. If and when directed energy systems reach operational maturity and the power generation requirements become manageable at the platform level, having a modular system like Loke ready to receive that capability is a significant advantage. The system also operates during redeployment, meaning it doesn't go blind when it's being moved. It can provide continuous protection while on the move, which in a dynamic combat environment is often when assets are most vulnerable, and it's designed from the ground up for seamless integration into layered air defense architectures. It can link with other sensors, communication networks, weapons platforms, and command and control systems to enable coordinated responses across an entire operational area. Zoom out and look at what LO represents in the larger context of where warfare is heading, and the picture becomes even more significant. The humble Iranian Shahed drone, a design that costs tens of thousands of dollars and can be produced at scale in days, has already changed warfare so profoundly that the United States military felt compelled to reverse engineer it and begin producing an American version. That is a remarkable development. The world's most technologically sophisticated military adapting to compete with a low-cost drone from a sanctioned country. The lesson is clear. In drone warfare, volume and cost effectiveness matter as much as technical sophistication. A swarm of 50 cheap drones is often more tactically effective than one expensive precision weapon, and far more difficult to defend against using traditional air defense systems. No system, no matter how advanced, can match the raw detection and interception capability of Patriot and the AAD against high-end threats. But against drone swarms, those systems are economically unsustainable. Ukraine could consume an entire year's global production of PAC-3 interceptors in months. The math breaks down. What NATO needs, what the LO is specifically designed to provide, is a cost-appropriate, rapidly deployable, modular layer of defense specifically optimized for drone threats. A system that can knock down a $50,000 drone without spending $3 million to do it. A system that can be in the field in 3 months. A system that can evolve as the threat evolves. 53 drones confirmed destroyed in 6 months at a NATO airbase in Poland. That is the Locke's answer. This is States News. The counter-drone arms race is moving faster than almost any other area of military development right now, and we're tracking every significant development as it happens. If you want to stay ahead of what's changing in global defense, make sure you're subscribed. The question of how NATO defends against the drone age doesn't have a single answer, but the LO just proved that one piece of that answer can be built, fielded, and combat tested in 84 days. And that changes everything about what's possible.